Class, do we adopt the Google Meet instead of the Kenneth conference? Okay, thank you. Okay, it's okay. I don't. We just have one person saying no. I think that's Finesse. The reasons are best known to him. I don't know why he's opposing the Google Meet to the Kenneth conference. One thing I know about the Kenneth conference, you use less bundles as opposed to when you are using the Google Meet. But let's just try to see how the Google Meet looks like. Then if it has a challenge, we can go back to the Kenneth conference. But for me, I believe it's a much better platform for us to have the class. So we look at the next model. The next model has been, or the next model, the name has been coined from the person who proposed the model, known as the Donald Norman. So some book will call this model the Donald Norman execution model. Some people or some books will also call it the execution evaluation model. So let's try to see how this model perceives the process of interaction with the system and how different it is from the GOMS model we looked at last week. This one is the most influential model in the human-computer interface. The reason being it's very straightforward. Once you go through the model, you are actually able to understand how interaction takes place between the system and the user. So as opposed to the other model, it's one of the most influential model that has been able to inform the user on how the how the interaction takes place between the user and the technology. Just like the name, we do have two phases. The first phase will be the execution part, whereby the user will submit their requirements on the interface. Then those requirements will be interpreted by the system. After an interpretation, the system shall be in a new state, and at that point, we can now be able to do some evaluation. We can be able to judge, has evaluation been successful or has it been a fail? Can see some students still coming very late to the class. So the first thing with the Donald Norman model or the Donald Norman execution model, the user will just form a goal, or you have to form the state. What do you want to achieve? For example, this state could be you want to search for a certain item from a website. This goal is the notion, or it's a notion of what needs to be done with respect to the task language. The task language will be that language which the user shall be using to communicate or to be able to manipulate the system. Once the user forms that goal or that notion or that state he wants to achieve, then the goal will be translated into what we call a specific intention. For example, the specific intention will be, I need to move the cursor. I need maybe, let's say, to decide on maybe which search mechanism I want to use. So first we do form the goal. After the goal, we transform that into a specific intention. And we also come up with the actual actions. What we need to be able to perform with the system so that we can be able to execute so that we can be able to achieve the goal. And these actions are the ones which are going to be executed by the system so that those actions can maybe activate some functions within the system so that we can be able to arrive at the goal. That's what we call forming a specific intention. And the intention would be, I want to achieve state A. And for me to maybe achieve state A, I need to be able to do 1, 2, 3 within the system. Once a part of that plan, those are the actions, all the entire plan has been executed, it's upon the user to be able to observe the interface And in this case, the interface will be that system. So it depends on how did you create the system. If let's say it's a web-based application, then I need to be able to observe that web-based application so that I can be able to evaluate the results of the executed plan and determine further actions. These further actions will determine, number one, was interaction successful or was interaction not successful? That's what we are going to be doing. After execution has been done, as a user, you need to be able to observe, or you need to be able to evaluate the user interface, then determine, do we need further action? If let's say I was searching for a certain product, or I was searching for something, I need to be able to observe the interface and see what results is the system returning for me. If the results being returned by the system are the ones I was looking for, then there's nothing for me, or there's nothing else I can do on the system. If you find that what is being displayed on the system doesn't meet your requirements, then at that time, you can determine further actions. Do you fine-tune the keywords? Do you, for example, add maybe more operators for you to be able to search, or for you to be able to maybe find the item you are looking for within the system? That's all about the Donald-Norman execution. Just a minute, let me admit some few students. So we can proceed. So we have said once a plan or a part of the plan has actually been executed, then it's upon you to be able to evaluate the system and now make a decision. Do we need further actions, or are the current actions okay? If at all the system shall be reflecting the goal you are looking for, then at this point we can now say that interaction was successful. Otherwise, if let's say what you see on the system doesn't reflect the goal you are looking for, then it means interaction was not successful, and maybe we need to formulate a new goal and replicate the cycle. If let's say I was searching for a certain item from my system, but I find that the results being returned by the system are not the ones I was looking for, at that time I can now formulate a new goal, or I can now repeat the same cycle, but maybe I might determine that the actions which I specified were not enough for me to arrive at the goal. That's all about the Donald-Norman execution. Can see a lot of students are coming very late for the class. Sorry, can just continue. I thought someone wanted to join the class. So the Donald-Norman model, we can be able to subdivide it into 7 further stages. Number one, it's you, the user, formulating the goal. Once you formulate the goal, you also formulate the intention. What do you want to achieve within the system? After the user formulating the intention, they can be able to specify the actions, and this could be in terms of sequence on the interface. For example, I want to copy from location A to location B. So on the interface, that's what I'm going to do. Maybe I'm going to select what I want to copy, right click, then select maybe copy. Or I'm going to select, then maybe use the keyboard keys, the Control plus the C key. Then I move the contents to where I want to move those contents to. And that's what we are doing in stage number 3. Once that has been done, once you now specify the actions on the interface, and this interface is the system you have been able to create all the piece of technology, the user can now be able to execute the action. So this action could maybe involve moving the cursor and maybe clicking on something for the actions to be executed by the system. And after stage number 4, then at that point we can be able to say execution has been able to occur. From 5, 6, and 7, that's the time we are now evaluating the system. So the user will now be able to observe the system and perceive the system state. What is the new state of the system? After perceiving the system state, maybe it could be in terms of a graph that is being displayed there. It could be maybe some kind of a report that has been maybe displayed on the system. That's what we are calling perceiving or understanding the system state. We can make an interpretation of the current system state. Does it match my goal, which I established at stage number 1? Then number 7, we now evaluate the system state with respect to the goals and intentions. At that point, we now make a decision. Either interaction was successful or interaction was not successful. If at all, maybe what we see on the system is not what we are, maybe what we are anticipating to get from the system, then we can determine that that interaction wasn't successful. But this model has a number of problems. So class, if you look at from step number 1 to step number 7, do we see a problem with this model? Step number 1, step number 2, step number 3, 4, 5, 6, and 7. Do we see, or can we be able to perceive a certain problem with the model? We can also use the chat on the Google Meet to share our answers. Do we see any problem with that model? Class, do we see a problem with the model? We have the 7 stages. Just look at them keenly. Is there a problem you can see with those 7 stages? Feel free to type on the chat. Maybe what you think could be the problem with the 7 stages. Hello, class. We do have the 7 stages projected on the screen. Just look at them keenly, then try to see whether we could have all this a problem you can see with the 7 stages of the interaction. Can give you 1 minute to do your reaction before we proceed. So we can just type on the chat the problem you see with that, with the 7 stages, then we proceed. Or we can also use our microphones. Okay, I can see Tony. How does the user perceive the system in number 5? Perceiving the system simply means you are trying to understand the change that has been able to occur on the system what this model is trying to do, there's some part being done on the execution. But anytime a system undergoes some kind of a transition, the system will be able to render the outputs of the transition or the execution. This is what the user will be able to perceive. Are you able to comprehend what is on the interface? That's what we are calling perceiving. If let's say it's a graph, can I be able to comprehend this graph with maybe what I was expecting with the system? If you don't maybe perceive, if you're not able to interpret what's on the interface, then it means we do have a challenge with, or we do actually have a challenge with the interaction between the user and the system. Because what happens if I communicate to a system, but I don't get what I was supposed to be getting from the system? It means obvious that that interaction is not successful. If I'm looking for maybe, let's say, a student maybe who did a certain exam, but this system cannot be able to give me that information, then it means that interaction is not successful from the user's point of view. Rubies, the user is being forced to do a lot of work. I can see you have a rough idea of what the problem with the model could be. Dennis, I think a user makes an execution mistake. He or she might end up being biased. Okay. Rubies was almost close to this. If you look at those 7 stages, we are all talking about one participant. We are all talking about the user. We are not trying to talk about the system. And this one has actually been one of the this one has been the major weakness being attributed to this model we call the Donald-Norman model. All attempts in terms of execution, in terms of interaction, we look at them from the perspective of the user. We are not looking at interaction from the perspective of the system. And we shall now be looking at another model that will be trying to solve this problem. We don't just look at the user, but we also try to look at the system, because execution is about the system and the user. We cannot just look at one aspect. We look at both. So the main weakness with the model is actually that we are looking at interaction from just one perspective, not all perspectives. So we look at this model will be able to explain to us why some interfaces usually have some kind of a problem. So let me just go through again the model. This model, Donald used this model to be able to explain to us why some interface might cause some problem to their users. And Norman used 2 terms to be able to explain. So Norman used 2 terms to be able to explain these problems which user face with the interface in terms of 2. We have the gulf of execution, and we also have what we call the gulfs of evaluation. I want us to look at what the 2 terms means and how maybe they cause a problem when we are trying to interact with our systems. Gulf of execution will mean the difference between the user formulation of actions to reach a certain goal and those actions allowed by the system. If you find there's going to be any difference between the actions which are allowed by the system and those actions the user which the user has been able to formulate to reach to the goal, then we do call that one the gulf of execution. I will give you an example. Assuming maybe I want to maybe copy and paste, but I find my browser doesn't support that maybe option, and maybe in the formulation of my actions, I said, for you to move maybe text from location A to location B, you need to select the text, then right click and then click, or maybe click on the copy function. But you find maybe the system or the interface doesn't support the right clicking. That's going to be a clear example of the gulf of execution. Any difference between the actions which the user can be able to use to perform a certain task and those actions allowed by the system, that's what we are calling the gulf of execution. If we're told that the actions allowed by the system will be mapping or will correspond to those actions which have been intended by the user, then it means interaction will be very effective from the user's point of view. If let's say I want to copy and I've said for me to copy, I select, then right click, then maybe select from the pop-up, I select, let's say copy, and the system maybe asks those actions, or those actions correspond to what the system maybe offers to the user, then that interaction will be very successful for the user. From human-computer interface point of view, an interface should be able to reduce the gulf of execution. The wider the gulf of execution, then the problem you'll find the user will have when they are communicating with the system. So as much as possible, when we are creating system, from human-computer interface point of view, we want to be able to reduce the gulf of execution so that those actions the user has been able to formulate can be able to map correctly to the actions allowed by the system. Do we have someone who is typing something? Sorry, I thought someone wanted to join the meeting, but they have just disappeared again. So that's what we call the gap of execution. So let's look at the other problem with the interface. It's what we call the gulf of evaluation. The gulf of evaluation doesn't talk about the distance, doesn't talk about the difference, but it's that distance between the user expectations of the changed system and the actual physical representation of the system state. In short, what it means, after execution has been able to occur, there's that expectation of the user of what they need to see on the system. But if you find there's a big difference or there's a big distance between what I was perceiving or what I thought the system will be able to display with what the system has been able to display, then we do call that one in human-computer interface gulf of evaluation. Assuming, for example, let's say I was searching for, maybe I was looking at some report of a system, but instead of the system maybe displaying for me the report, they display something different. Or let's say I was looking for a pie chart, but instead of the system displaying for me the pie chart, the system displays for me a bar chart. Then that one will be a clear example of gulf of execution. Because what I was expecting from the system and what I can be able to see from the actual physical representation of the system are actually totally different. If at all the user can be able to evaluate, let me just admit that student. So if at all the user can be able to evaluate easily the presentation in terms of his or her goal, then we can say that gulf of evaluation is minimal. Maybe let's say you have a picture of, let's say it's a picture of a dog. This is just an abstract example. Assuming the system has been able to represent a picture of a dog, and maybe what you see from your end is a picture of a cat, then we can say there's a very big gulf of evaluation. But if the system represents a dog and you can be able to perceive that this is a dog, then we can be able to say then interaction is more successful from the user's point of view. These students who are joining so late. So we just continue. It's just some interruption from students joining very late for the class, but we proceed. The more effort you feel that you require to be able to interpret representation on the system, then it means that interaction is not successful or it's not effective at all. At all times, you should be using less effort for you to be able to see or to be able to perceive what is on the system. If more effort is required, then it means that interaction has not been very successful. And remember, from human-computer interface, we want to be able to improve interaction between the user and that piece of technology. So this model tries to make us understand interaction in a more clear manner, in a more intuitive manner, in a manner you can be able to understand in a layout without a lot of problems. As I said, the main problem with this model, it tries to concentrate only on the user interaction. If you look at those 7 stages, we are all talking about one person. The user, the user, the user. There is no one point whereby we were talking about the system. So the model doesn't attempt to, or does not attempt to deal with the system communication through the user interface. And we do have another model that will be trying to look at how can we be able to incorporate the system when we are looking at interaction, instead of just looking at the user, the user, the user, because that's not the only participant in communication. The model was taken further by these 2 guys, Abowd and Beale, and now they came up with a new model or a new framework, a new interaction model we call the Abowd and Beale interaction framework. This framework simply extends what the Donald Norman execution model did in 1991. And instead of just looking at the 2 components, Abowd and Beale decided to look at communication as consisting of 4 items. We do have the user, we do have the input, we do have the system, and we actually have the output. So that's how Abowd and Beale interaction framework perceives interaction to occur in systems. Between the 4 components, we have 4 translations. For example, from the user to the input, we do have what we call articulation. From the input to the system, we do have the performance. So both the articulation and performance will be consisting of the execution phase. That's what we can actually be able to term as execution, articulation and performance. Then presentation and observation, the 2 of them will be consisting of evaluation of the system once the execution has been able to occur on the system. And this is how the model actually looks like. As I said, we do have the user. So that task which the user wants to do within the system shall be articulated using a language we call the task language. And it's very clear that the user, the only way they can be able to manipulate our system, the output and the input, it's actually, let's say, the interface which the user and the system are using to communicate. Could be like a web application, could be like a web form. So that one will be articulated in a language we call the task language. After the articulation has been done, the input will now be transformed by the system operations to something we call performance. And we are saying articulation and performance will be consisting of the execution phase. So between the user and the system, these 2 phases or these translations are what we are calling the execution phase. At this point, the system shall be in a new state. Maybe the system has been able to go some kind of transformation, and through that transformation, the system is now in a new state, which will now be presented on an output on the interface. This, for example, could be a graph on your system. This maybe could be on your form, but that presentation will be rendered on maybe on an output, could be in terms of a report. Between the output and the user, we are doing something we are calling observation. It's upon the user to be able to look at the output, what has been rendered on the output, and make a decision. Have we been all the output I see on the the output I see on the interface, does it meet my user requirements? If not, we formulate some new task to achieve the goal again, then we repeat the cycle again. Actually, there's no difference between the Abowd and Beale interaction framework. The only difference will be we have not been able to model, or we have been able to bring the user, we have been able to bring the interface as a component in the interaction. But the Donald execution model was not talking about the interface. The Donald model was only talking about the system and the user alone. Just a minute, please, class. Let me pick this. Okay. Hello?
Hey, Kyoko.
Yes? Jema. Deno, yes. Yeah. Sorry for that. Japheth, let me just pick this question which I was not able to pick as I was explaining. Can we say execution is a mismatch between the user interaction and can we say execution is a mismatch between the user intentions and the allowable actions in the system? I mean, okay, the gulf of execution. So the gulf of execution simply means, maybe I can just explain it further. Sorry, I missed that question. The gulf of execution means, yes, there are some actions which are allowed by the system, but the user will formulate some actions on how he perceives, on how maybe he perceives on how the interaction is supposed to take place. But something might happen that you find some actions which the user has are not being supported by the system. For example, I know some browsers will not be able to support the control and C, or control and X, and so on and so on, those shortcuts. But maybe I, as the user, formulated the actions as follows: for me to move the contents from location A to location B, select the item, then right-click the item, and maybe select the copy from the pop-up. But you find the system doesn't allow that. Once there's that kind of a mismatch between those actions allowed by the system and those ones the user has been able to formulate, that's what we are calling the gulf of execution. Japheth, I don't know whether that's much clear. And sorry, I actually missed that question. Sometimes when you are projecting the slide, you might not be able to see all the students' requests. Japheth. Okay, we just proceed. So we just continue with our model. So each of these components have its own unique language. So if the user will be using a language we call the task language, the input will be using a language we call the input language. The system will use a language we call the call language. The output will use a language we call the output language. So each of that component on this model, we are going to be using a very unique language. So system and the user are not using their same language. Sorry, the output and the input are also totally using their own language. As I've said, the input and the output will form the interface, and that will be the interface the user will be using to be able to manipulate your system. That system maybe could be, let's say, like a web page, which you are using to manipulate your system. That's how simple this interaction looks like. The extension is something very minimal, but it's always very important in systems. When you are going to be doing your projects in 4th year, what I always expect a student to be able to do, you can take something that was done by another person, look at the weakness of that maybe work of that person, then try to incorporate a new way to solve that problem by critiquing what the other person did. That's what these two guys have done. They looked at the Donald-Norman execution model. They saw a weakness. After the weakness, they were able to model interaction in a different way. And that's all about research. Try to see the problems being all in a certain research, then present them in another way that can be able to solve the problem at hand. So we can just explain into detail before we actually finish this chapter on the interaction. So the only way the user can be able to manipulate the system is via the input, and that input will be the interface. This one usually begins by the user formulating what goal do they want to achieve with the system. Maybe I want to search for a certain student within the system. I want maybe find a certain product from eBay. I want to maybe find a certain product from Jumia. That's your goal. And after formulating the goal and the task, that one will be articulated in what we call the input language, because the only way the user can be able to manipulate the system is via the input. Once we have the input, or once we have the input language, or once we have been able to present what we want to be able to perform with the system using the input language, and in this case, the input language could be the programming language you're using. The input language will be now translated again, or your input, which has been rendered on the interface, will be translated as the operations which needs to be performed by the system. And at that time, the system shall be using the core language, because number one, the system has to understand what operations are we performing on the system. So your input will be translated to the operations by the core language. That one will be done by your system. And that means the system which maybe the user has been able to create. As a result, the system will be able to transform itself based on how we were able to interpret the input. So based on the transformation that occurred on the input, or based on the operation that we are supposed to be doing, then the system can now be able to transform itself. For example, maybe the user was trying to log in the user was trying to log into the system. So the operation which will now be translating in this case will be the system will try to get we try to authenticate the user maybe from the database. Those might be the operations which needs to be performed by the system. It depends on what kind of task were you formulating what kind of task were you formulating, and how will the system be able to translate itself. Once that has been done, then we can say execution it's now complete, and we can now begin the evaluation phase of the interaction. As I said, the first two transitions, the articulation and also what we are calling the performance, those two translation will enable us to be able to execute the operations on the system. Our system is in a new state. Once we are in a new state, then we need to begin the evaluation. We need to confirm, was that interaction successful? So let's see what happens in the evaluation. At this point, our system will be in a new state, and this new state must be communicated to the user. the user need to be able to see after the operation that were done by the system, this is the current state of the system. These are the new attributes. These new attributes could be, for example, the user has been able to log in. These new attributes could be, for example, the user is able to find that item they were searching for from the internet. This new attribute could be the user has been able to find that particular student they were looking for within the system. So those outputs will be now rendered as concepts for features of the output. So you'll now be able to see on the interface the output of the execution phase. And at that time, we are saying the system is in a new state. It's not in the old state it was before the transformation occurred. Upon this time, it's now upon the user to be able to look upon the output on the user interface and either assess was interaction successful or not. The output I see on the screen, the output I see on the interface, does it match my original goals? If not, then we have to repeat this cycle again. There's no difference between this model and the Donald-Norman execution model. The difference will be very minimal. What these guys have been able to bring, we are bringing in the user interface, we have brought in the system, we have brought in the user separately, and we are also looking at the transitions. So if I now look at the interface, if I look at the output and make an assessment whether the original goal has been met, we can now determine either to repeat the cycle again or to end the execution, interaction at that point. And we can say that this one will complete the evaluation phase, and also the interaction cycle will also end at that point. That one will mark the end of the Abowd and Beale interaction framework. So I think this is something we have already discussed. There are 4 transitions between the user and the input. We do have articulation. Between the input and the system, we do have the performance. And these two, up to this point, there's a way I could have drawn the line. Sorry, just a minute. So up to that point, I think this is what we are calling execution. This is what we are calling execution. At the top there, this is what we are calling our evaluation. So it's that simple. Articulation performance will form the execution phase, while presentation and observation will form the evaluation phase. And it's that simple in Abowd and Beale model. On that, the fact that we have brought the user interface, the system, and the user separately, that's what just makes this model different from the Donald-Norman execution model. But if you look at the model, it's almost exactly the other model we have looked at. I think this one is something we have already done. We don't need to go through it. Maybe these are just some entry points for the 3 models. Number 1, discuss how the Abowd and Beale interaction framework work. You may use an example in your discussion. Since we are also preparing ourselves for the exams, anytime you are given a question, then you are asked with an example, we are not very sure whether we are going to be doing the face-to-face exams or we are going to be doing online exams. We might be forced to do the face-to-face exams, or maybe we could be doing the online exam. I don't know which is which, but whichever way, we are ready for any of them. So if you are asked in any exam to explain something, then you see another portion, use an example. most students, what I've seen them doing, maybe let me just explain with this example. So most students will just look at this part. They'll read that part, then they'll just discuss the Abowd and Beale interaction framework, and then they just feel that they have answered the question as expected. Maybe that explanation, this explanation alone, sorry, let me a minute. Maybe this question, could be having something like 15 marks. Sorry, 15 marks. But you might not be able to get all the 15 marks from just explaining the model. So you might find, for example, 10 marks will be for just explanation. This one will be for explanation. Then another 5 marks will be for the example. But a student might decide that, or they may just see the first portion of the question. In any exam, whether it's mine or any other person, try to see how many parts of that question are you supposed to answer. Also, try to see the weighting of the questions. You cannot just get 15 marks by just writing one page. If let's say it's a normal face-to-face exam. If let's say you have been asked to explain a certain concept, then make sure that you explain the concept very well. Don't just state facts. Make sure that the concepts are very well explained. In your explanation, you can even maybe use some examples to explain what you have been asked. The reason why you find maybe you're expecting an N and you get a B or a C, it's because of these few marks. These examples you shall carry a lot of marks. If the question was for 4 marks, maybe 2 marks could be for the example. And if you end up missing 2 marks for each question, then at the end of the day, you're going to be getting 35, but you just feel you got everything in that exam. Okay, then this is another example regarding the GOMS model. Explain how you would use the GOMS model to search for a certain product. So explain how you would use the GOMS model to search for a certain product. I hope you can be able to remember the GOMS model. So if you are given this kind of a question, number 1, you formulate the goal. The goal is to search for the product. Come up with the operators. How can you be able to search for this product? What are the physical actions? What are the cognitive actions? What are the mental processes you need to be able to undertake for you to search for the product? Once that has been done, look at the methods. How many ways can you be able to search for this product? Then, if the methods are more than one, in most cases, the methods will be more than one, you'll be expected to come up with a selection rule. If this is equal to this, then you can use this method. Else, use this method. Else, do this. That's the GOMS model. And I believe we did the GOMS model last week. Then, explain the Donald model of interaction. Use an example to demonstrate how the model works. This one, you have also been asked to give some examples. That means as you're explaining some parts, you are going to be giving some examples in between. Some further reading suggestions. Beyond Human-Computer Interaction, which is the core book I'm using for human-computer interaction. From page 124 to 130, then you'll get the 3 models. The GOMS, you'll get the Abowd and Beale model, and you'll also get the Donald-Norman execution model. And that will summarize those models before we move on to chapter 4. Could we be having a question, class, before we move on to our chapter 4? Do we do a break of 10 minutes, then we come back? Okay, so let's come back at 35 minutes past 12. So let's just have a 10-minute break, then we come back at 12:35. It's now 12:25.